Hello members, in this discussion we are looking for the volume bounded by y is equal to x squared and y is equal to 2x and the curve or function f of xy is equal to 3x squared minus 3xy squared. So first of all, what do we need to do? Let's first do a simple sketch and we see how we can proceed with this. This is y, this is z, which is giving us the magnitude of our f of x equal to 3x squared minus 3xy squared. And then in this direction, we have x. So we want to look at where is this curve x squared. Y is equal to x squared is around here. If this is the origin, then the 2x also passes through the origin. Y is equal to 2x also passes through the origin. And we are saying this is y is equal to 2x and this is y is equal to x squared. Now the region that we are interested in is this. So if I look at this region, then I move it up so that it forms a solid substance. Then I'm looking for the volume of that substance. How do I get it? Usually, we find that we need to integrate using a double integral of this function, integrating this double function 3x squared minus 3xy squared, okay, with respect to x and maybe with respect to y. But what becomes our limits is a problem. So we want to look at where the two curves meet. Maybe that could give us the limits. Let's first start with that. So we want to look at point of intersection. So at point of intersection of y is equal to x squared and y is equal to 2x, we see that they share a common point of y, but the values of x are different. So we have a point here and we have a point there. So meaning at the point of intersection, y must equal to 2x must equal to x squared. So if I proceed to deal with the right hand side, I will have 2x equal to x squared. So x squared minus 2x is equal to 0. So x, if I factorize it out, I'll have minus 2 is equal to 0. So either x is equal to 0 or x is equal to 2. So now, if x is equal to 0, what is y? Y is equal to 2 into 0 and is also equal to 0. So if it is equal to 2, y is equal to 2 into 2, which gives me 4. Meaning that where we have a point of intersection, for the side of y it will be 4, and here it will be 2. Yes. So now let's proceed and see. If we integrated, this is what is inside here is the x. So the limits that we are going to put here are going to be those of x. So 0 to 2, and this is going to be 0 to 4. But now if we integrate that, it means that we are going to be dealing with this region. Let me use a better one. So that means we are going to be taking the whole of this region. So which is not what we are interested in. We are interested in a solid substance that is going to be around here. We are talking about this. So how do we get that? What we are going to do, we are going to keep our, for example, one of these limits is going to remain constant and the other limits are going to vary along a given axis. For example, if we maintain the limits of x to be 0 to 2, then the limits of y are going to be varying along the x-axis. So what am I trying to say? I'm saying if I say I'm going to integrate from 0 to 2, that means the x limits are going to remain constant, then those of y are going to change. And this is what we are going to do. We are going to say that where x is equal to 0, okay, where x is equal to 0, we are going to move integrating the side of y, okay, the side of y is going to move from y is equal to x squared up to y is equal to 2x of 3x squared minus 3xy squared with respect. So here we have with respect to y, okay, and with respect to x. If we don't want to do that, then we can make y remain constant, then we vary the dimensions of y along x-axis. So how do we do that? We already know that our y is equal to 2x, the first y. So meaning that your x will be y out of 2. So if y is equal to x squared, that means x is equal to square root of y. And then I'm going to have this volume also being from, this is now going to be 0 to 4. Then I vary those of x so that I have x is equal to what? X is going to be equal to the square root. I can take y out of 2, then square root of y of 3x squared minus 3xy squared. Then I integrate what is inside with respect to x and then with respect to y. But I find while evaluating limits, I meet a challenge of the square root of y. So if I want to move very fast, I avoid this root and I go with this. So that means I'm going to have my volume, which is going to be integrated from 0 to 2. Then I integrate from x squared to 2x, okay, of 3x squared minus 3xy squared with respect to y, with respect to y, with respect to x. So it is a good practice to begin with what is inside here, then later on proceed with the limits of 0 to 2 while integrating with respect to x. So I will have x squared 2x 3x squared minus 3xy squared, then dy. So if I integrate this, I'll have 3x squared y minus 3x, then y cubed out of 3, evaluated from x squared to 2x. So this gives us, by putting 2x, it's become 3x squared into 2x minus 3x out of 3 into 2x power 3. Then I subtract, if I put in x squared, it's become 3x power 4, yes. Then minus this and that will go. Then x times x squared cubed, so this becomes x power 7. Yes, but then because of this minus that was here, this becomes a positive. Yes, so here this becomes 6x cubed, and this and that will go, so that I will have minus 8x power 4, because this is 8x cubed times x, which becomes 8x power 4 minus 3x power 4, then plus x power 7, which is equal to 6x cubed minus 11x power 4 plus x power 7. Then I come again and integrate from 0 to 2, of 6x cubed minus 11x power 4 plus x power 7 with respect to x. So what is this going to give us? It's going to give us 6x power 4 out of 4 minus 11x power 5 divided by 5 plus x power 8 out of 8 from 0 to 2. Now, if I do the evaluation of this, it's going to give me, this is 6 out of, so it becomes 3 out of 2 into 2 power 4 minus 11 out of 5 into 2 power 5 plus 2 power 8 out of 8, then minus 0. So if I do this, finally, this is what I'm going to get. I'm going to have this being 2 to power this becomes 16. 16 divided by this, I get 8, so that will be 24 minus 70.5, then plus 32. So I find that I have negative 14.4. So that would mean the volume itself is going to be 14.4 cubic units. If we are talking about volume, that's how we can deal with this problem.